Okay, so then let's jump into it, right? Let's just go. Okay, that's the me reviewing my stuff. All right, events and errors. Okay, so in this presentation, we'll be going over the two kind of basic tools you have access to when you make a frame palette that allows you to express what's going on, like how things are going. Usually, again, events are things good, errors, things are bad. You want to tell the user, tell the front end, tell your whole runtime that these things are happening. So events and errors are basically that. And really, they're quite simple. So let's start with errors. So not all extrinsics are valid, right? You are defining a state machine. The state machine has a set of valid states it can be in, right? Users in using your blockchain system are expected to be malicious. They're expected to want to mess up your state machine for their advantage, right? These are publicly accessible blockchains. They have publicly accessible APIs. Anyone will want to tinker with it and mess things up. If you actually look at the history of blockchain, every single like hack or exploit is just some user finding an invalid state and sticking your contract or your blockchain in that state, right? Like it's not really a hack. These things are kind of well defined. It's just that they found some kind of exploit kind of thing. So it's important that you detect and you check all the time that your state machine is valid. And if the user is trying to do something which is invalid, that you give them an error. And giving them an error is not a impolite thing. It's not saying naughty naughty. It's just saying, hey, you maybe you're mistaken or whatever, but we are not going to accept this state transition function, right? But we are still going to charge a fee, right? That you're making us do some work, we still take your fee, but nothing's going to change underneath, right? And we talked about in the storage layers that if you return an error from your call, we revert all the storage changes, right? Yeah, so again, state transition function might allow something. Maybe it's a timing problem, like you're trying to close a proposal too early. It might be a lack of resources. Maybe you don't have enough funds to pay for a transaction, right? It could be that the state transition might be waiting on other processes or other data, right? It might be that, for example, if I want to submit a call, I'm still waiting for the pre-image of the call or something like that, right? A million reasons why you can imagine something goes wrong. So all palette calls return this thing called a dispatch result, right? And a dispatch result is really simple. I think you might have played with things like this inside of your other coding, right? It's just a result. A result has either OK with the empty unit in this case, or error with a dispatch error, okay? You'll also note for those who are working on the free transaction palette, obviously you return this dispatch error with post info. I don't think I really cover it in this presentation, but it's basically the same thing, but it has additional information on top of it, right? It's allowing you to like remove the transaction fee or whatever. If you want to look into that more, you can go into Polkadot and you can search that type and you can see the additional fields, right? But practically speaking, for most people here, you just have this dispatch result. It's either OK with unit type or error. So let's look at the dispatch error. So if you actually go into, this is a little bit out of date, Polkadot SDK, substrate, primitives, runtime source lib, you'll see this enum, which is the dispatch error, right? And there's a few I just want to highlight inside of here. There's a bunch of them, but a few that are kind of more relevant. The first is other. You can see other here is a static string. So basically, if you're just hacking some code together and you want to return just a string as an error, you can do that, and all the code will compile it. Now, you'll notice that it has codec skip. So we won't actually take the strings you write and turn them into the runtime. These are mostly for like tests and stuff. But the idea is that if you're writing some quick tests, whatever, you want to turn an error that says checking 1, 2, 3, you can do that real quick. You don't have to necessarily go through the process of actually making a valid, like a proper palette error, all that kind of stuff. So something that we support. Although this is fine to use for like setting things up quickly, I don't expect to see any static string errors in any of these things. There's no reason you can't just make a new enum variant. It's it literally takes a second. Okay. Next one, bad origin. So every single call kind of starts with this origin check, this ensure sign, stuff like that. If that fails, you're getting a bad origin error. So it's a kind of clear distinction between like there's something happening at the origin level rather than your palette, right? There's something is not being valid in terms of like access to the function. And then of course we have a variant called module, and this is where your palette errors come in. So and the word module is kind of historical. Before they were called palettes, they were called modules, right? And that's kind of a more general term. But if you all have module errors, And so whenever you emit an error from your palette, it'll be under this variant. And you can see here the variant has some subtype, which will actually be your specific errors. And we'll talk about breaking that down a little bit more. Okay, so what does a module error look like? So if we go into the same file, we'll see here actually there's a struct module error. And the module error has an index, has a error with some encoded size, some potentially encoded data, and an optional message which doesn't get encoded in. Okay? The index describes your module index. So when you create your runtime and you have system palette, dex palette, this palette, etc., each of this is an index, right? These are all the different indexes of modules. So when we emit an error from your palette has a unique index, and we describe that here. So that's how we're able to know which palette the error is coming from. We just have an index to tell us which palette is coming from. Next, the error message. So normally, errors are just an enum variant, right? So you normally have like, okay, bad, like not enough payments, bad inputs, bad outputs, whatever, these different variants. And I think you've seen the errors in your palette. Should be pretty simple. That really just needs 1 byte, right? So you can imagine that on the most cases, the error here is just 1 byte telling you which variant, right? So with this 2 information, if I emit an error, I can know from the 2 bytes which palette it's coming from, what error they're emitting, right? But we also support a little bit of extra data in the error if you want. You can see here, we allow an error of encoded size up to 4 bytes, right? And we can actually support errors that have up to 4 bytes of information. Now, 4 bytes isn't a lot, but what it is useful for is nesting errors. For example, we talked about the palettes being connected together. I could have a my palette, which is connected to the balances palette. The balances palette might return an error, not enough funds. And I might return an error when you called create pool, you didn't have enough funds. So I can actually nest create pool error, not enough funds from balances. And you can imagine, again, we're able to encode that additional where the balances error in this additional bytes. That's why we only allow a little bit. We don't want to shove a lot of data into errors, right? But we can allow a little bit of nesting errors. And I think this came up most frequently. I think we added this feature specifically around XEM. So XEM is kind of a complex system. There's a lot of ways something can happen. We wanted to express these errors kind of more easy to understand what things are happening. So we had this nested error here to allow for a more specificity, right, in the error message. And then of course there's the static string. So I expect to see on every single error and every single event in your runtime a very nice documented comment on what is happening. And it's not for me, it's for your users. If you actually, and I should show this in an example, if you actually go and you click the buttons inside of Polkadot.js and you make an error, it doesn't pop, a string pops up telling you that. And that string comes from your code comments. Some of you have already talked about inside of chat, you're talking about the scale info, right? There's like an error about this type info. What's actually happening is that there are macros which are actually capturing all the text that you write on top of these errors and events and palette calls, etc. And they're turning it into the metadata. So all of this content is not actually just dev code, but it's actually user-facing text as well. So when you click a button and it says, the error string is not enough balance, you could actually say, I'm sorry, user, you don't have enough balance. You need to do that. Like you could actually write that and it would show it to the user. And that's happening here. Now, of course, this doesn't get baked into like all of the WASM. But usually what you can do is you can generate a WASM which has this extra metadata, or you can generate metadata with this information in it, and then you have a connection between that error and that actual text, right? So please write very nice error messages, not only for me, but so that your users and UI can actually access that information and make it pretty, okay?
Are we also going to do the metadata part? Like,
I don't think we have a presentation on metadata, but I'm happy to talk about it if we get a little time at the end. So please just remind me, okay? But I'll briefly say, there's not a lot to say here, but metadata is quite powerful. Basically, as you've already heard with scale is a non-descriptive format. Is that the right word right here? That basically you only get the data, you don't get the description of what the data means. In order for you to decode things in scale, you need to know this is the structure I want to create, and then I'll use the data to deserialize it, right? That this is the general principle we use for the entire blockchain stack. There's no reason every single time we make calls to one another that you need to describe to me your message, I need to describe to you the output, right? This is a lot of wasted bytes. Imagine every single time I say this field, this field, this field with strings or whatever in JSON format, and you have to parse it, and then I tell you back a bunch of things with JSON format. It's just tons of waste information where there's a concrete state machine and a concrete definition of these products. Instead, we wrap all of this metadata into a metadata. And one time when you connect to me, we give you the metadata, and from this point forward, we now have a definition for how to communicate with one another. We don't have to pass back and forth always all these fields, all these structures. We have a single metadata, and we're able to talk with it. And this, again, is a mindset of how we can optimize behaviors between users and products like the blockchain, right? So this is an optimization, but one that really pays off in terms of things like clients. Imagine that you're running the future we believe in with Web3 is that people are going to have access to these blockchains from their mobile phones, from their mobile wallets, whatever kind of they want. All of those bytes are cost to you, are cost of scaling the network, right? So we want to really optimize this thing. We have metadata capture all this information in a concrete spot. So again, that's kind of the high level idea, but I'll show you if you want a little bit more exactly what's happening there. I feel like I'm talking fast. No one has. Okay. Well, no one is shaking their hands yet, so I'm not gonna, not gonna slow down until. Yes. What do I need? Oh, my hands free. Sure. Okay.
It's a bit off topic, but you just said that we pass metadata only once, right?
Well, like the first time you connect to the node.
Is that the reason why in smart contracts you usually have this ABI file that you need to import?
Yeah, the ABI file is basically the same thing. It's like a metadata. It's exactly the same thing. Yeah. Exactly. Okay. But our metadata is like levels above. Like our metadata tells you the name of the chain, the units of the thing. It tells you what pallets are in your blockchain. It tells you all this stuff. Like, has anyone here used the Polkadot.js API? Right? When you connect to a new blockchain, it just knows what pallets you have. It is able to actually even construct fields for you to interact with your UI, right? Like that happens automatically because it can actually parse your metadata. So it's quite powerful. Like again, if you follow the tutorial I described with the proof of existence, you open that UI and it just had a way to hash a file. You didn't write that code. It wasn't pre-prepared. It just knows because your type in that thing expects a hash. The JS is smart and can say, okay, well, the metadata says use a hash. Let me give you a hash function, right? It's very cool. Okay, declaring errors. Okay, so go back here. So this was the insides of an error. This is what's happening when you actually declare it, but this is the background. This is the data being passed. You're not actually dealing with this type. What you're doing simply is in a palette, right, with all the different parts, you are declaring an error. It's an enum. It has simple variants. You can see here we don't have any additional bytes, but you could imagine having another field in here with another enum in it, right? So again, up to 4 bytes maximum. And it just, tells you the field. So again, this palette in the runtime has an index. This enum, this is index 0, index 1. You can imagine how we can define what error each thing is. And again, these are those comments that will show up to users. So write them. And then if you want to actually use an error, it's pretty simple, right? Because these calls, they return a dispatch result, right? The error type of the module error is already supported inside of here, right? So if you just, OK or return your error type, it will get converted to the dispatch error, right? Yeah, what I'm saying is that the metadata will have this text. So when you make a UI using Polkadot.js and you get the error into the JS thing, not only will it tell you exactly the error message, which module, which palette, which error it is, but it will actually also contain this text that you could display to the user if you want to. Right? Comment on that? Yeah. Yeah, okay, so the question, why 3 slashes out of 2? 3 slashes in Rust is a documentation comment. So actually, if you put 2 slashes, it won't show up in the metadata. 3 comment slashes is a documentation format. I don't know if this is only Rust, but this is the way. So, yeah. Exactly. And for example, when you generate the Rust docs, this this double slash comment won't be in the Rust docs. This triple line comment will be in the Rust docs. Okay? So it's just documentation. Okay. Right, yeah, so you can, again, you can return the error. You can return the error whenever you have something happening here, okay? Using errors. So errors are not only great for users to see, but for you to ensure that your state transition function is erroring as you expect. I do not want to see, here's some transaction which should error. Does it error? Okay. I want to see this error matches the error I expect, right? I want you to directly assert that the error that's happening is the error you expect. And so you can go ahead and do that using the tools like assert no-op. It will have a function which returns a result. It expects an error, and you can compare it directly to the error that you expect. And again, no-op, in addition to assert error, assert no-op ensures that no storage was modified at the end of the transaction. Okay? So I expect to see, again, when we talked about tests here, I expect to see all the amazing positive conditions of your functions and test for every single error that can happen, and you doing this comparison to show that this error happened. Yeah.
For multi-line documentation comments, just 3 dashes, and then 3 dashes, and then 3 dashes.
Yeah.
Yeah.
All right. Encoding errors. So this is going back to your scale knowledge. Hopefully you still remember the scale talks. So let's just take an idea of what this is. I told you what the actual underlying type looks like. Let's actually see how it encodes differently. So we start with just an error, no owner, encode, right? This is the first variant. Let's go back, sorry, here. There's variant 1, variant 2, right? So the first item in the most raw case encodes to 0. This second item encodes to 1, right? But then if we into our palette error type, into the dispatch error type, which has all these variants in it, then you start to see the palette, which is palette number 3, or index 3, the variant, let me see, wait, sorry, did I don't make a mistake here. Yeah, this is the variant of the thing. Oh yeah, this is module error. So the 3 tells us this is a module error. This tells us the palette number, and then this tells us the variant of the enum, right? So the first byte here goes back to this one, right? It's telling me of the dispatch errors, it's variant, or the fourth variant, index 3, module error. So this is, I'm getting a module error from palette 2 or 1. I mean, I don't know the best way to, I'm just going to say the number, and then you will know in your head index 0, okay? So from palette 1, and variant 0, variant 1, and the unused 3 bytes, right? We're not using those 3 bytes right now. So that's exactly what you're seeing. So again, when we actually pass the error up, it's converting from this simple palette error to a dispatch error, right? And again, encoding is exactly what you would expect. Yeah. Module, palette 2, error 2, unused and unused. And it's based on the configuration, right? So this was the thing. There's 2 palettes, etc. Great. So again, I mentioned here we have additional bytes. We allow nested errors. And again, I actually don't expect you to use this inside your palettes. Your palettes are not complicated enough probably for this. But feel free to try it out. It's not a problem. You can basically create another enum, like a sub error, and then you can include those sub errors in your error enums, right? And if you try to put more bytes, like you can even put a U16 in there if you want. But if you try to put more bytes than that, you'll get some kind of compiler error, right? So maximum of additional 4 bytes. Okay. Any questions on errors? It's pretty straightforward, I think.
What is the maximum additional 4 bytes?
What is it? What its purpose, or what am I talking about? I'm talking about.
I missed
Yeah, I'm talking about this. This 4 bytes. We support an error variant with 4 bytes in there, and so what I'm saying is that feature is specifically to enable exactly this. That if we only supported 1 byte, you wouldn't be able to do this, because this is 2 bytes of data. Okay. No questions. Yeah, super easy. Do you have a question? Sorry, then let's get a mic to him, please.
error variant can be any struct, provided it's 2 byte.
You can put anything inside of, you can put anything inside of here which encodes the scale and is less than 4 bytes.
Okay, inside item should be less than 4 bytes. Okay, so I can put a string as well instead of
Less than
U16.
3. No, but U16 is U16 4, it's 4 bytes. I think it's 4 additional bytes. Let me see, what am I saying here? This, oh yeah, 3 additional bytes. Total of 4 bytes. Yeah, okay, you're right. So maybe I have maybe this is wrong. Okay. In any case, there's some limit, okay? You'll figure it out through hardcore. But what I'm saying is whatever can fit in there to these rules, and you'll get an error if it doesn't fit.
Got it. Thank you.
Yeah. If you can, maybe send me a message on Discord to fix this slide. Sorry. Thank you. That's you. I like the way you think. That's even better. Okay, so let's talk about events. Okay, we talked about the error situation, very simple. Let's talk about events. Events are basically the same, but a little bit more complicated. We'll get into that. Okay, so when an extrinsic completes successfully, there's often some metadata you might want to express to the outside world about exactly what happened, right? Like there could be multiple success conditions. There could be multiple things that have happened when a success happens. Like you can imagine that your transaction triggers a bunch of other, dominoes of things, and a bunch of things happen, and you want to express that to the world, right? So events are really kind of a way for you to express those ideas. I'll add to this, events are things that are commonly indexed by block explorers. So if you've ever gone to Subscan or whatever, you could actually see every single balance transfer by just querying the events and seeing, okay, all the times that an event has happened. Or let's say every single time a pair chain has won an auction because of the events there. So again, events are a tool used inside of the ecosystem to index important things, right? Block explorers or GraphQL libraries or whatever will actually index events to ensure these are the events that are happening, right? So let's do the same thing. Let's kind of break down the steps of declaring events. First, events are something which so how do I describe this? Unlike errors are just bytes that get propagated up the Rust stack. Events are things which are used by frame system. Frame system takes an event and puts it into storage for you. Okay, so that it can be propagated around. For that reason, when we create a bunch of events from a bunch of different palettes, we need to accumulate all those events into a single type. And this is my talk later in the day about outer enums. But we need to accumulate these types together. And for that, we need to define a runtime event type. So again, you have a palette event. In your runtime, there are many palettes. And there could be one overall type. We call this an outer enum, which can represent all events in your runtime. So this type represents events from your palette, but also represents events from other palettes too. Okay? And that's kind of what these trait bounds are doing. So you see, it can be from my event, and it is supported for the frame system events. Again, if this doesn't make sense, we're going to have a talk later in the day. But for this reason, whenever you use events, you must include in your config this line. And so I think we've included it for you, not only in the very first tutorial you did, but in all of your projects. It's just a standard line. And actually, we have some macro code, which if you try to use an event and you don't have this line, will tell you, hey, you're missing this line. This is a very just standard copy and paste. This is what you need. Yep.
I think I might know the answer, but if we're putting events in storage at the end, how are they different than storage? And I think the answer is that events have a constant value, but I don't know.
No, so events are put into storage, but I might note this in my presentation. We never read from events. So events, they exist in storage. They have an impact on your storage, but we ensure that no one ever reads them. Because if we read them, then we'll have problems with parachains, like with events. So events are mainly write only.
Okay, but
They're write
do
only.
they also contain variable data or?
Yeah, exactly. So,
So you
they
can say event
they can contain
A,
much
event
more data, and I'll show you that.
like the type can be event A, and the data in it can be like ABC.
How about you let me show you in the next
All right,
slides?
yeah.
Okay.
Events are right only means we don't test them.
You can read them in tests, but inside of the runtime, you should never read them, and I'll tell you why.
You have slides showing how to test them.
Yeah.
Okay.
I have everything.
I guess you're gonna answer that, but in particular, I guess the whole notion is that events are getting published and there's like an external service and that captures it and indexes, quote unquote.
Yep.
Okay, got it. And what is the data format in which the event messages are stored?
Yeah. Let's go. Let's
Okay,
go. Let's go to the
great.
next slide. I think all the
Thanks.
same stuff I showed you before. I think I'll show you again. All right. So there's an event. You need this type. You need to have it in your config. Every single palette that uses events has this config. Okay. Then just like before, you have an enum of events, and you can just put your enum there. And then when you want to deposit an event, you use this self-deposit event. And so actually, if we go back to here, let's go back 2 slides, or here, or here. You see that not only is there palette event, there's this palette generate deposit function deposit event. There's a little bit of macro magic here. Again, as I mentioned, events are deposited to frame system. So there's some code which does that. We generate that code for you automatically. So, I told you before, I didn't like generating the getter, but actually I do like generating this because this is a little bit complicated. And I think I show you what that code looks like. But we can use basically self-deposit event, which is a function being generated by that macro, and just drop the event that we want, right? In the success case. So again, deposit event. We have this additional line, which is generating function for you. This is exactly the function. If you do cargo expand, you'll see the function. There's no reason you can't write it. You can delete this line and you can write this in your code instead. But this thing has 3 arrow brackets on it. You don't want to write this code. I don't know what it means, So I just take it. It works. That's just the ecosystem. And again, this is one of those things. Like this is actually kind of powerful, right? That you don't have to write this. Rust can write it for you, but do so in a very safe way, right? This is the advantage of using Rust and Substrate as a framework. Okay? Okay. Events are just a storage item in frame system. So if we go into frame system, we'll see a storage for events and for the event counts, how many events are inside of the block, right? And so it's just a vector with event things in it. Okay? We also have some notes here. Look at this. Note, this item is unbounded. So remember how we talked about bounded items? This is a vector that's unbounded. Note, the item is unbounded and should therefore never be read on chain. It could otherwise inflate the POV size of a block. Have we talked about POV yet? This is something that will come up in Polkadot. So let's not talk about it now, but when you're learning about Polkadot and parachains, remember this concept of POV, okay? What is what? POV stands for proof of validity. Okay. Events have a large in-memory size. Box the events to not go out of memory, just in case someone still reads them from within the runtime. So that's the idea. But I'll show you. I think we have functions which say don't do this. So we deposit events in frame system, and then there's this function here which actually populates the events and pushes it in. So if you go back to this function we generate, we call into here palette deposit event, right? And that calls basically this deposit event indexed, and that actually goes and puts the item inside of the storage, right? Simple enough, right? Yeah. Put it, and we do append. And by the way, we use this append API, okay, to be able to quickly insert things into the vec, right? I think I told you that actually this change to use the append API, it was a 90% increase in performance. You can imagine why. Imagine that we are adding events. Every single time I read the whole event, add one, put it back, read the whole event, add one, put it back. It was extremely inefficient. One more thing to note. This is super important. You are going to run into this error. Pay attention. You're going to run into this error when you write tests. If your block number is 0, we don't emit events. There's a line of code here that says that just return if the block number is 0. That means when you're writing your palette code, set block number 1 if you want to check the events that are being deposited. The reason we do this is that in the Genesis block, imagine you have like 1 million accounts you're populating. It generates tons of events. Like the creation of the first block is super slow and super heavy if we have events in there. So we just skip the Genesis block and we do it. But that means in your tests, if you don't set the block number to 1, you're not going to be able to do event testing, okay? You cannot read events, as I mentioned. So events are unbounded vector here. They're emitted by your palettes. If you ever read the storage item, you'll introduce the whole thing into your storage proof. Again, this is something that will be more relevant when we talk about Polkadot, okay? Never write runtime logic with reads or depends on events. There are some people, they have intuition or some kind of feeling that they want to read an event and use it as a hook to some kind of on-chain execution. It is not the way to do it. There are other ways to hook or to trigger information across palettes. You will never, ever, ever, ever read from events, okay? But tests are okay. Tests don't matter because it's not the real blockchain environment. And we even in our APIs really ensure this. So the function that is exposed to you is read events, no consensus. If you want to read events, you can. Again, there's a function for it. But you're writing read events, no consensus. I know what I'm doing. I'm shooting myself in the foot. Please don't do that. You know, this is your choice to do it. Inside of tests, we support just a function called events. So that's more easy to access. It works inside of tests, okay? Remember to set the block number to 1. So inside of a test, you can call this set block number function. This is a function that's only available in tests. It comes from frame system. And then you can ensure that we actually put the event. What is this other code here? So you can set the block number. You can assert a block has an event. So you can actually pass an event and check that there's at least one instance of it. Or you can assert the last event was the event you expect. So all of these are tools that you can use in testing. So here's an example. I'm writing a test. First thing I do is I set the block number to 1, right? Then I do some function call or some storage stuff. I assign some messages, etc. And then I can assert the length of the events. I can say events, the length is 3. I can assert that it has some event. Here, like owner changed from 1 to new, that somewhere in the things that I did, there's an event, owner changed 1 to 2. And I can assert the last event was owner changed from 3 to 4. All of this passes, okay? Remember, other palettes can deposit events too. You might think that you had the last event in there, but it could be actually another palette had the last event, right? So you just, don't pull your hair out if something weird is happening, right? Every palette is going and depositing events. Is there a comment on that? Yeah.
I'm just trying to compare it to, Ethereum, where I believe when you do event logging in Ethereum, you can define a type of index or key.
Yeah, index things. Yeah, we have that too, but that's not a normal. Right now, it's not really used in the palettes. But if you go back to here, deposit event calls deposit event indexed, and indexed actually has here. How do I go back? The topics, and this is exactly the same terminology in Ethereum.
Got it.
This I think is only used inside of the contract environments, inside of the contract palette, inside of the EVM palette.
Got it.
But inside of palettes themselves, I don't think it's actually necessary.
Got it. Thank you.
Okay. Okay, so in summary, events and errors are 2 ways you can actually signal to users what is happening when they dispatch an extrinsic. Events usually signify some kind of successful thing happening. Errors signify when something has gone bad. And both are accessible by the end user when they occur. Any questions or comments on events and errors? Practically speaking, when you use them, you're just creating 2 simple enums. The way that I add events and errors is that I start writing my code. If I need an error, I add one real quick into the enum, and then I use it. Right? I'm not necessarily like, oh, what are all possible errors? Let me create it first. It's like I'm adding them, removing them as they go. But I expect to see that when I review your code, that you're not leaving behind a bunch of artifacts. Don't leave behind the template errors. Don't leave behind errors which aren't being called. I'll check this kind of stuff. You want to make sure to clean up your palette, clean up the stuff that you're doing here, okay? Any other comments?